Hello students, today I am going to discuss with you the important topics for Physics ICSE 2023. So without wasting any time, let us see. The first chapter, that is force. For force, you can see that I have mentioned two topics. One is moment of force and the other one is center of gravity. So whenever I mention topic, in my previous videos also I have told you all the things under that particular topic. Whatever is present in that topic, you have to cover everything under that topic. So when I talk about moment of force, I'll just give you a bit of briefing. You have to define the moment of force, you have to do the definition, you have to do the units, the SI as well as the CGS unit. Also, please see the relationship between them, the SI and the CGS unit. Okay. And the most important thing under moment of force, which I think that this year it will be there, that is a numerical on the moment of force. Okay, so numerical, basically every year they give one numerical from moment of force, so numerical you should not give a miss. Okay, now when I talk about the numerical under the moment of force, there can be indirect questions on equilibrium. Okay, questions on equilibrium can be there. Questions on equilibrium, I'm writing it so that you guys can take a screenshot of it. So equilibrium, there can be indirect questions on equilibrium. Okay, and also there will be questions on clockwise and anti-clockwise moment. Clockwise and anti-clockwise moment. Okay, so this is all you need to do under moment of force. The next is center of gravity. For center of gravity, you have to know the center of gravity of the regular objects. Where does the center of gravity of the regular objects lie? Be it a triangular lamina or a ring, all the objects, all the regular objects. And also you, in your syllabus, you have the center of gravity for an irregular lamina. So you need to know how to calculate the center of gravity of a irregular lamina. Okay, now do the definition. You should know, see, you're doing the center of gravity, you should know the definition of center of gravity. There are certain rules and conditions mentioned in the book, so go through them as well. Okay, as they're important for short questions. Okay, now coming to work and energy. So from work and energy, the first topic you can see is work done. Now under work done, what kind of question will come? You know there are three types of work done: positive, negative, and zero work done, right? So you should know one example from each. Apart from one example of each, there can be situational wise questions. They can give you a situation and they can ask you what kind of work is done in this situation. Okay, suppose they give you a pulley is lifting a load. So when the pulley is lifting a load, number one, what kind of work is done by the pulley? Number two, what kind of work is done by the force of gravity? Okay, so you need to know that. Then coming to kinetic and potential energy. So for kinetic and potential energy, just you need to know the expression for both. The normal expression we all know, the kinetic energy equals to half mv square, potential energy is equals to mgh, right? But you should also know the expression for the change in kinetic energy, which is half m v square minus u square. Okay, and change in potential energy, which is equals to mg h2 minus h1. So they may give you a question like the initial velocity is v, u, and the final velocity is v. What will be the change in the kinetic energy? All right, or they may give you that a object is carried from height h1 to h2. What would be the change in the potential energy? Questions are related like this. I told you a very simple version of it, but yeah, you got to figure out, you if you have the concept of this, you will be able to answer all questions related to this. Then you have the numerical on kinetic and potential energy. Okay, and finally the interconversion meaning that you have to do the conversion of kinetic energy to potential energy or potential energy to kinetic energy. So they can give you a situation where kinetic energy is getting converted to potential energy, or potential energy is getting converted to kinetic energy. For example, in a pendulum, right? What happens in a pendulum when it is in the mean position, then when it goes to the extreme position? So what is the energy over here? What is the energy at this point? What is the energy? Suppose A, B, C, at the extreme position, at the mean positions. Okay, what is the total energy? So that also includes law of conservation of energy. So law of conservation of energy, you can say, you can do the not definition, state the law of conservation of energy. I'm sorry, state the law of conservation of energy. And again, the example of simple pendulum. And one more example is there, which I think is more important for this year, that is ball falling from a height. But do both. Okay. All right. Then we have the examples of energy conversion, like electrical energy. Name a device where electrical energy is converted to sound energy, or give an example where electrical energy is converted to mechanical energy. Or suppose they give you an example of microphone and they ask you that what kind of energy conversion is taking place in it. Lastly, you have a relation between kWh and SI unit of energy. What is kWh? Kilowatt hour. What is it basically? It is the commercial unit of energy. What is it? Commercial unit of energy. All right. So how this commercial unit of energy is related to the SI unit of energy, that is joules. Okay, you must have practiced this kind of question. So this is important. So go through this. Next, you have pulleys. For pulley, you do firstly the most important, which comes every year, that is the block and tackle system. Block and tackle system. Don't miss it. It has to be there in any form. Okay, so block and tackle system. And secondly, I think this year movable pulley is important. So there can be a question on movable pulley. Okay, so the mechanical advantage, the velocity ratio, the efficiency, all this of a movable pulley. Okay, there can be a question like this. It came actually in 1 year, and I think they may give this kind of question this year as well. Here you can see there's a fixed pulley and a movable pulley. This is the effort, this is the load, and these are the tensions acting. Okay, so they can ask you questions that what is the effort needed to lift this load? What kind of pulley is this pulley A? What kind of pulley is this pulley B? Okay, this kind of question from this particular diagram. Also, when you're doing machines, please don't miss the relationship between mechanical advantage, velocity ratio, and efficiency. Okay. The next topic is light. The next chapter is light. From light, I feel rectangular glass slab. So when we are doing rectangular glass slab, that means the ray diagram. In the ray diagram, guys, please don't miss the arrows. Use scale pencil. Okay. So the ray diagram, and also you're doing the ray diagram, that means you know the concept of lateral displacement, right? So that covers lateral displacement. Then total internal reflection. Now, when you're doing total internal reflection, it covers critical angle also. Without critical angle, you cannot explain total internal reflection. So you should know critical angle. Then the conditions for total internal reflection, right? Then you have complete the path of the ray. So they may give a rectangular glass slab. Okay, and you have to complete the path of the ray. So this covers. They may give you a situation in the rectangular glass slab where total internal reflection is happening. So this is also covered. They may give you a prism also. So yeah, so all these, even if they give you the complete the path of the ray of the question, so these total internal reflection, critical angle, all these will be put into the concept. Then numerical of real depth and apparent depth, there's a simple formula. You have to go through that and practice numerical on that. I think it may come this year. And then come the most important topic of this year, that is minimum deviation. So I think the graph on minimum deviation. You should, I actually tell about the graph to the students every year. I tell it's important, please don't miss it. It comes, it doesn't come, we'll see that later, don't miss that. Okay, so please do the graph for the minimum deviation. Okay, and if you can do questions on minimum deviation, some numerical. I don't think it is important for this year, but just do it. You should know the formula, and it's very simple, so it may take just 5 minutes of yours. Okay, so yes, the factors affecting the minimum deviation, factors affecting the minimum deviation, the factors affecting the angle of deviation, rather, you can do that. Okay, the wavelength, how does the wavelength is affected? Okay, how does the refractive index of the material of the prism, how does angle of deviation depends on the refractive index of the material of the prism, how does it depends on the wavelength of light? So you have to do this. Okay, so apart from the topics which I have written over here, what I am speaking, you should note that too. Okay, then something I've not mentioned over here is spectrum of light. So please do spectrum of light. Okay, you know the spectrum of light, when light disperses, 7 colors are formed, Vibgyor. So which of them has maximum speed, which one has maximum wavelength, all these questions can be there. And finally, the most important one which I have missed over here, which is every year it is there, no teacher will tell you to miss that, and that is image formation by lens. All of them. When you're doing the image formation, be very, very particular with the measurements. Okay, use scale, pencil, compass, and make sure you don't miss on the arrows. Okay, yeah. Next is sound. For sound, you have to do echo. Now for echo, what is an echo? So define. Next is the conditions for the formation of echo. Very, very important. Okay, applications, very, very important, like sonar, ultrasonography. Okay, so you need to do why we use the ultrasonic waves. These are important things. Okay, then one more thing is there, numerical. Every year, this year also, I think numerical is very, very important. I don't know how much these three are going to come or not, but numerical must. So you have to do numericals on echo. Okay, then types of vibrations. So the 3 types of vibrations are there: natural, damped, and force. Their graphs. Okay, how they are represented on graphs. And when I talk about forced vibration, indirectly your resonance also comes into the picture, so you have to do resonance as well. Okay, so make sure you do everything, because from this now they'll give you conceptual questions, they'll give you a situation, they'll ask you the type of vibrations maybe. Okay, so please do everything under natural, damped, and force vibrations, including the examples, resonance, the reasoning, the graphs. All right. Then we have current electricity. Current electricity is basically numericals, and numericals. So you should not miss on the numericals. Okay. So numerical could be to calculate the total resistance, to calculate the total current or current through a resistor. Okay. Calculate current. So yes. Okay. Then you have to, yes, find the equivalent resistance, calculate equivalent resistance. Okay. So this is also very, very important. You must have done. Now, when you're doing current electricity, this is the heart of the chapter. This is the heart of the chapter. Okay, so it must be done, it must be done. So you should know Ohm's law, the conditions, the violations, the VI curve. So when we draw a VI curve like this is the VI curve which obeys Ohm's law, right? So they may ask you questions, what does the slope of this curve tells about? Okay, so slope tells us about the resistance, right? Now suppose they give you an IV curve, don't get confused. If it is an IV curve, the slope tells us 1 by R, that is inverse of resistance, which is actually conductance. Okay, then ohmic and non-ohmic resistor, what are they? With example and graph. And from household circuits, I have not mentioned over here in my previous important topic video. I have mentioned on household circuits. This year I would say that plug and socket, color coding, and earthing. Okay. So yeah, these three I think are important, but I would suggest you, if you could, it will be very nice if you would solve last 5 year questions from household circuit, last 5 years questions. Okay, that excluding the part which is not there in your syllabus, like the staircase wiring, the household wiring system, ring wiring system, all these are not there in your syllabus, so you need to exclude that. Then you have the magnetic effect of current. Students, AC motor, DC generators, these are not there in your syllabus. So from magnetic effect of current, I'll tell you, my suggestion would be do the last 10 years question, excluding the unimportant topics. Okay. And see, the most important, if you say that, ma'am, still if you tell me that what would be the important thing, then I would tell you circuit diagram to find the polarity. Circuit, one question, guaranteed. Okay. Circuit diagram, according to me, to find polarity. So there will be one question on this. Then Fleming's left hand rule. There can be a question on Fleming's left hand rule. Or they'll ask you to what rule did you apply to find the polarity. Okay. So it comes into the picture. Fleming's left hand rule or Fleming's hand rule. All right. Then, yeah, that's all. According to me, it will be better if you solve the last 10 years question again, I would say. Then we have heat. Under heat, you do the specific heat capacity. Now when you're doing the specific heat capacity, you also do the heat capacity. So under specific heat capacity, what all will be there? Define. Then the SI unit of specific heat capacity. Then reasoning on specific heat capacity, reasoning questions. Okay. Then relation between heat capacity and specific heat capacity. Relation between heat capacity and specific heat capacity. All right. Then you have graphical questions pertaining to phase change. That means they can give you a graph and they can ask you that at what point boiling is taking place, what is the melting point, what is the boiling point, or at which portion of the graph shows that there is a phase change, or which portion of the graph shows constant temperature or no phase change. All these kind of questions can be there on phase change. Okay, so a graphical questions is expected to come this year. Okay, then next question could be on latent heat of questions, latent heat of fusion. So on latent heat of fusion, usually there are reasoning questions. Okay. So just check on the reasoning questions from latent heat of fusion, especially latent heat of fusion of water. Okay. Then we have calorimetry. Now under calorimetry, I would say do everything. Okay, so you should know what is a calorimeter, the parts, construction, principle of calorimetry, principle. Okay, and numericals. Obviously one numerical would be there. Okay, so this would be for heat. And for our last topic, that is modern physics, which I have missed over here. Modern physics, again, guys, I would say please go through the last 10 years questions. Okay, and obviously exclude the part which is not there in your syllabus, that is the nuclear fission and nuclear fusion, that won't come. So properties of alpha, beta, gamma particles, go through that. Alpha, beta and gamma emission, do that. Okay, radioisotopes and its uses. So these things are important in modern physics. Best would be last 5 years or last 10 years questions nikalo and go through that, do that. Okay. And guys, the last thing which I would like to mention you is that all these suggestions, the topics which I have given you is I have done, I have taken it out after going through the previous year's question papers, the trends, which is there. Okay, the school papers, the of many renowned schools. Okay, so yes, these are the important suggestions. So those who have done their preparation from the beginning, these topics would be a revision topics for them. They could give some extra efforts and focus to these particular topics. And those who haven't done from the beginning of the year, I would say that guys, please solve last 5 years question. This is your time. If you want to do your give your exam well, please solve last 5 years question paper and also these particular topics. Okay, and I have one video which I have uploaded for these the important tips how you can write your paper. Sometimes what happens, we study very nicely but we are not able to write, put it on the paper nicely. So that is also very very important. So I have made a video on that long back. So I'll just share the link in the description box so that you can see that video as well. Okay, so guys, all the best for your exam. Hope this video helps you. In case if you need any other help, please let me know. Take care and bye bye.